Hello guys, today I'm going to do a kind of special video. I'm going to show you how I design my projects and how I test them. In this case, I'm going to talk about the seat mover project that failed the last week. As you can see, it's quite a basic thing. You have a rail here where you are going to put your seat, and you have a bar and a crank linked to a motor, and that's it. So first, how I designed it, it took about a month to draw it. Um, so basically, I started with something like this with basically two PLA 3D printed parts, the green one and the yellow one. You have two pillar blocks there, the rail, the motor. Then a little bit later, I just optimized a little bit this part, the yellow one. I replaced this thing with a bearing. You can see there M6 board that help to mount the motor on the aluminum profile. The goal at the beginning was to design a seat mover that could be mounted on basically any aluminum profile based rig. This one is the NSH rig that I have, but in theory, we could have mounted it on anything. So here, what is new? You have here the block where you have the rails for the seats, and below the rail where the seat mover will be moving. But nothing really new there. You have here the motor mount. It was really well made because you have here two M6 boards to fix the motor, and then you could install everything, the mechanical parts, the electronical parts, as we will see later. And yeah, it was really well designed, very easy to mount and dismount. And so yeah, next, nothing really new. You can see here the M6 bars. You have the M6 bars goes in this part, and you also have two extra screws there that will attach there. So a really strong mount with 4 points. Then I swapped, as you can see, the yellow parts for a mechanical one with two end rods. This is standard parts that are easily available. They are cheaper, and because they are in metal, they are basically unbreakable. So it was really the way to go. And it also has had a little bit of freedom to correct any misalignment. So yeah, it was the thing that has to be done to replace once again that yellow part. You have also the start and end switches that help to calibrate the system. I think a lot about how to mount them. Here you can see the switches mount is mounted on the rig, but I also think about mounting those switches directly on the rail, and I ended up with mounting them directly on the motor support, so you have all the electronic in just one place, easy to remove and to put back again, and you don't have to have a specific rig to place your switches or anything. So it was really better this way. And by the way, at that point, I think I thought, oh yeah, it isn't my rig there. I mean that my seat doesn't sit there, they sit in another aluminum profile there. You will see that later on the pictures. So I have to change a lot of things. As you can see, the end rods is quite far from this part now. So, but I think okay, well, in the worst case, I just have to put the end rod there instead of the other side. So it wasn't a big deal. And once again, because you have freedom with this rod, you can correct this. You also see there a system to block the whole thing, to block the seat. It is really important now when I create my projects. I, I think about a way to make my rig usable, even if I'm testing some things. Before I often have my rig off because I was testing some things, actuators, pedals, and it's very uncomfortable to have your rig off 1 month or 2 months just because you are testing something. So from the beginning, I'm thinking about a way to maintain my rig okay. So this was the system I designed. So the white part is mounted on the rig, and I just have to add the red part to block everything, and that's it. As you can see there, you have the servo driver. I have two versions of this project. I have this one with a servo motor. It was designed for a MiG 80 M04025 that outputs 4 newton meters. And I also designed another version for a stepper motor. It is the stepper motor I use for my actuators, the SRT100, and it outputs 12 newton meters. So it is very powerful, and there isn't so many difference in the design. It's just basically here the part here isn't the same diameter, and the bars aren't in exactly the same place, but that's all. So yeah, I designed the two versions. Obviously I had this motor because I am using them for the actuators, and the servo motor is the one I used a long time ago for my Simulcube, my direct drive, but it was becoming so hard when using them that I changed. So yeah, I it basically took a month to draw everything. You basically see there the, the the multiple steps. As you can see, the design evolved when drawing, thinking about it. Sometimes you have mistakes in the design. Just here, basically, the seat just doesn't sit there, and yeah, I drew this project for hours before thinking, well, this is wrong. So yeah. Okay, so now I'm going to show you how I test this project. So I printed everything. I printed the model mount 3 times. The first one wasn't okay. There was still an error about where the boards are fixed. So just a small error, but if you can't mount the motor, it won't work. And the third time to just have the support motor for the servo motor. I tested the two models. So yeah, here are the pictures now. So here the parts. You have here the rail coming from industry and CNC, very smooth, very well made. You have here the system to block everything. The crank here, that isn't the good one. I think, yeah, it isn't the good one, but anyway, The right one is almost the same. The end rods, here you can see some mechanical parts. In fact, it is the mechanical parts from my first Martian rigs years ago. Maybe you saw it on X Simulator years ago. As you can see, the the old SRT pedals. Yeah, and it was 2 degrees of freedom. You have here a pivot. You have here the motor and the crank, the bar, and it is 12 millimeters. So I took those parts. I had. It is a little bit too big, as you can see, but it's free. So okay. So I removed my seat. You can see there the SRT100 control box, the newer version with those 3-pin connectors. Here the control box for the seat belt, a stepper driver, a bass checker. So as you can see, there is a lot of things just under my seat. But thanks to this, I don't have anything else outside of my rig. So I'm really happy with this design. As I said, you can see here the seat just sits there on those aluminum profiles and not there on the outside. So I just had to change some things. Okay, so I removed also those rails, and I just have this. So you have the M8 nuts. Here it was a lost M4 bots. I had problems with the parallelism between those extrusions and the whole seat. As you can see, there is narrower than here, and I think the same here. It is narrower than here. It is the NSH rig, but it isn't the standard design. When NSH sent me this rig, those aluminum profiles were sitting there on those aluminum profiles, and the parallelism was okay. But I wanted to have my seat lower. I wanted to lower my center of gravity to avoid to have my rig moving too much. And yeah, once again, it is my bad. Okay, so let's start. So that was in the morning. I mounted the rails, as you can see, and the stop system. I had a lot of issue with those carriage coming off of those rails and with bars everywhere. It happened so many times this day, and yeah, I lost maybe 1 hour due to this, because once you put the balls back in the mechanical part here, you have to dismount everything to put back the carriage without having those balls coming off. So yeah, really bad. Okay, those end rods in 12mm were too big and were touching the 3D printed parts here, so I had to print spaces. Glad I have the 3D printers, because once again you always need something else, and thanks to this 3D printers you can have it really quickly. As you may have understand, you don't have enough space here for the stop system and the mechanical system, so I moved the stop system at the back. You can see there, and it works perfectly. Here this small part can be removed by hand, and really does the job. I tested it, it holds on, it didn't break. I didn't test it for hours, but it really did the job, so I was really happy with it. And having this system helped me to to block the system and to avoid to have the carriage coming off the rails so often. But I didn't have this system at the other side, and the other side came off really often. Here you have the shaft, the threaded shaft, the nut, nothing else. I think here is the crank to have my parts as sturdy as possible. I usually use screws that come through all the parts. The problem is that here it is M3, I think, and you won't find M3 by, I don't know, 50 millimeters. And with the standard design, I just have my screw here. So I took my drill and I made it. How can I say? More deeper, and it's very uncommon that you can fix your 3D printed parts with a drill, and most of the time you have to print the part again. It can take hours, it can take a day or two sometimes. So here I was really happy to fix this part with just a drill. So you can see here the 4 holes have been modified, and now my screws are coming off enough. Here is the rail. I don't know why, but I was sure that it used M4 bolts, and now it is using M3 bolts. So I didn't have T-nuts for those screws, so once again I had to print those shitty T-nuts here, and it does the job because you don't have so much forces on those rails. You have obviously the weight of the driver, but you don't have to overcome the braking forces or anything, because when you brake you just have your parts moving, but the rail doesn't do anything in this. So it did the job, but once again, when I design and test my projects, even if I spend a lot of time thinking about it, thinking about the shopping list, I always have missing parts, and sometimes 3D printing can do the job, sometimes not, and you can lose 1 month. By example, one part later, this part, I order this one for the other model, and I think it's always stuck with the customs, and it's been more than a month. So as you can see, it really can take a lot of times, and as said before, if you need these parts to have your rig functional, you have 1 month where you can't use your rig. So that did the job. As you can see there, once again, the rails, everything is okay. I can put back my seat, and once again I had so many troubles with those carriages coming off. Here it can't move, but here it can. Here you have a stop, but you don't have here the same here. So yeah, I struggle a lot with those things. I lost so many time with those things, but now it's okay. The seat is back. Here you can see the shaft ready to be mounted. A view from under the seat. You can see that everything is put tight, but it does the job. And my mess. I'm basically walking on the floor. I think I'm used to this since I was a kid playing Lego on the floor, and I'm really comfortable on the floor, you know, where when you walk on the floor you can't have your tools falling, and yeah, I'm used to this. Beside of this, I don't have a table to walk on, and I'm in a flat. I don't have those big shiny white table to work. It is really tiny. You can see there the foldable seat. It is where my desk is sitting, and when I'm working, I have to put back the seat. So you understand that I don't have so many room here, so I do with what I have. Um, okay, next, my M6 bought reserve. Um, because I'm working on a lot of projects, I really have to have all the screws, all the sizes. If not, I just lost so many time because you have to change the side of the 3D printed parts to be compatible with the boards you have in stock, etc. So I really spend a lot of money in screws to have them all. The stepper motor with the coupler it is basically two parts, male and female, and you have one part that have a conic shape, and when you tie them together, this shape just come against the shaft, and it is very strong, very nice. You probably already saw this part if you have seen YouTube. So the motor is mounted on the motor mount. You can see there the two M6 boards that come in the support. I usually make my own cable. I really think that it is the more reliable way to work. Before I was using, the jumpers that you can find in Arduino kits, but I really found out that they aren't so reliable. It is never the good length, so now I always do my own cables. It doesn't take so much time, and then you really have the right thing. So you can see the Dupont connectors. And now the Arduino with the two switches, and we are ready to test. So the calibration was really simple. When you plug the Arduino, the motor starts to rotate back until it presses the switch at the back, and then it would go in the other way until it contacts the front switches. So you have the Arduino monitor here that says wait until the crank presses the switch at the back. When it presses the switch at the back, you know that you are in the low position. You go the other way, and when you press the front switch, you know that your position is the maximum position. It may sound simple. It may sound simple, but I think I spent 2 or 3 hours trying to make this code work. And in fact, it was really hard. I don't know why. I've been working with stepper motor for years now, and it's still sometimes a problem. It was also a problem to link it to FlyPT. So you can see there, you have the motor moving one way, and when it touches the switch, it goes the other way. You can see there that it works as it's meant to be, and later you will see that it didn't work later. So everything is ready now. I can mount the crank. The Arduino goes below the motor mount. In my project, I always think from the beginning at a place to mount the controller, because I know that if my controller is just lying on the ground, I will have my cable pulled off. I will have trouble, and this is really the guarantee to have your thing reliable. So yeah, something quite simple, but it really did the job. I think the problem with this design is that because it's on the low part, the gravity may pull the cable off, but I didn't have any problem with that. So I really liked the design of the motor mount. Once again, you can really assemble everything, test everything, and in the end you put it on your rig. So yeah, I really liked it. Another problem here, I had to remove those black bolts, and I couldn't use the wrench this way because as you can see I couldn't go deeper due to those plastic. So I did when I do my test, I always have those kind of problems. Sometimes it isn't that bad. Here it isn't a big deal, but sometimes it is. And now with the crank mounted, and finally the motor, everything is ready to be assembled and tested with FlyPT, and it don't work. So you will see there when I plug the Arduino, um, you will see the motor starts to move and then stop, and I don't know why. And I spent really hours to find the problem. And once again, it is very simple code. So in the end, I ended up just how can I say, counting the steps from the low part to the high part. And just when I connect FlyPT, I put the seat mover at the low part, and FlyPT knows that it's the low part, and that's it. So no calibration needed. And then it's mounted on the rig, so no problem there. It's mounted as expected, and I was really happy with this. As you can see, the end rod isn't mounted this side, is at the other side, but once again I have enough freedom in the design to handle those problems, and it failed. Yeah, it failed. The main problem, so I had a lot of problems with FlyPD, with the settings. I said to FlyPD to use those type of configuration with the rod, the crank, and it was acting a bit weird. So I just said to FlyPT, forget that, just think that it's a linear actuator, and it worked it worked better. The thing is that the motor isn't able to overcome the strength of the driver when the driver is braking, and I didn't thought that it would be that weak. This stepper motor is 12 Newton meter, so it's basically quite strong, and in fact it isn't strong enough. So I printed the other motor mount for the servo motor, and it was basically exactly the same. So good point for my motor, because it is the motor used for the SRT100 actuators. Once again, 12 Newton meter. The servo motor that I had is 4 Newton meter, and the servo motor used for OpenSFX are just 2.4 Newton meter. So as you can see, in the end, despite what I said when presenting, the SRT100 actuators, the motor I use for my actuators are in the end, in some way, stronger than the motor I use for OpenSFX. Well, the main difference is that with stepper motor you have the torque decreasing really quickly with the speed of the motor, while with the servo motor you keep a lot of torque even if the motor is rotating fast. So once again, I won't say that my motor are better than the motor for the OpenSFX actuators, but they are still really good. So that's it. It fails. It's not strong enough. I think one solution could be to use a really short crank here. I think it is 65 millimeter from the two axles, and we should use maybe 1 centimeter or less. And in fact, it wouldn't be a big deal. The system was designed to have a travel or about 8 centimeters. And when you think about it, I think that in the end, 4 centimeters in the front direction, 4 in the rear direction is maybe a little bit too much. Think about it. If you are pressing a accelerator pedal, you are in let's say a comfortable position. Nothing that the seat is moving 4 centimeters back. I think that you could feel a little bit uncomfortable. So yeah, it didn't work as expected, despite my experience, despite having spent 1 month designing the whole system. It took about 1 day and a half to test this system, to assemble everything. So yeah, as you can see, it can take a lot of time, a lot of money also. So here I already had the motor, the stepper motor, stepper driver, servo motor, but I had to buy the servo driver. I had to buy a lot of mechanical parts, and in the end, I don't use them. So yeah, I hope you like this video. I really wanted to show you how I do my projects. I try, I test, I think about them. Also, maybe show you how many errors we can do when designing those systems. Once again, despite the experience, despite the hours thinking about it, you can see that you never know what will happen, and it's really not that easy to create something out of the box. And yeah, I think that's it. Okay, once again, I hope you see the video, and I hope that we will see us soon for something that works. And I say you au revoir.